Okay, page 4, number 10 says a small soda costs 45 cents and a large soda costs 65 cents. 35 sodas were sold for a total of $18.55. How many of each size soda were sold? So in this problem, we should first read it carefully. Make sure you know what they tell you and what you're looking for. Here we're looking for two things. What are those two things that we are looking for? Look at the question. What does the question say? How many of each size soda were sold? So your two unknowns would be the number of small sodas and the number of large sodas. So our two unknowns would be small, the number of small sodas, and the number of large sodas. The problem does not tell us that. We need to figure out how many small and how many large. So since these are the two unknowns, we can use a variable to represent these unknown amounts. And normally we use the variables x and y. So what we're going to do here is we're going to assign small and large to be some variable. Let's call the number of small sodas, let's call that x. X would be the number of small sodas. And let's call the number of large sodas y. I'm just assigning x and y to be the number of small and the number of large. Now, the problem tells me two key pieces of information. The first sentence, as you can see, says this: a small soda costs 45 cents and a large soda costs 65 cents. So in that problem, would you agree? They're telling me about the amount of money that you would make from buying a small soda or a large soda, right? So there we have the cost in dollars, or in this case in cents, right? Because the sodas cost so many cents. The second piece of information comes from the second sentence. It says 35 sodas were sold for a total of $18.55. Okay, so we have the total cost in dollars, which is $18.55, and we have the total number of sodas, which is how many? How many sodas were sold? 35, right? And so we're going to use those two key pieces of information to set up two equations to make a system. Okay? So what about the cost? Let's call this equation number 1. Equation number 1. I have some small sodas, and how much is a small soda? What does it say in the problem? How much is a small soda? 45 cents, right? So I would represent that as 0.45. That's 45 cents. And it's 45 cents for every small soda, right? Or 45 cents times the number of small sodas. And we're letting x represent the number of small sodas. So 45 cents times the number of small sodas would of course give you the amount of money that you make off of small sodas. Plus, you're also selling some large sodas. And how much is a large soda? What does it say in the problem? It says 65 cents, right? So that would be 0.65. It's 65 cents for every large soda. So 65 cents times the number of large sodas, which we're letting y represent the large sodas. 45 cents for every small soda plus 65 cents for every large soda would equal how much total money? How much total money is made off of these sodas? What does it say in the problem? Well, it says 35 sodas were sold for $18.55. So here it should be $18.55. That is the total amount of money made off of the small sodas and the large sodas. So there's my first equation. Now my second equation should be talking about the number of sodas. The number of sodas. So what does it say about the number of small sodas? Well, I sell how many small? I don't know, right? That's my unknown. But I sell some number, which is x, plus some number of large equals how many total? How many total sodas were sold? 35, right? So now I have this system. My first equation is the cost in dollars, and my second equation is the number of sodas that are sold. Some number of small plus some number of large equals 35 total. Now here's my system. Here's my system right here. Now I just solve the system like normal. How do I solve? Well, I could use graphing if I wanted to. I could use substitution, or I could use elimination. How about let's use elimination, because we just got finished talking about that. To use elimination, we use LOAS, right? Line up, opposites, add, sub in. My system is lined up. X's are stacked, Y's are stacked, constants are stacked. and x and y are on the same side of the equal sign. Do I have opposite terms right now? No, I don't, right? Now, as you can see in that first equation, I have some decimals. I can get rid of those decimals, right? Can't I multiply by, in this case, 100, since there are 1, 2 places after the decimal, 1, 2 places after the decimal, 1, 2 places after the decimal. So I could move every decimal point 2 places to the right, which is the same thing as multiplying by 100. So what I'm going to do is, so I don't have to operate with decimals, I'm going to multiply that top equation by 100. Every term in the equation will get multiplied by 100. Okay, or that's the same thing as moving the decimal 2 places right. So 1, 2, this is now equation 1 now, this is 45x. I go 2 places to the right, 1, 2, this is now positive 65y. I go 2 places to the right, 1, 2, this is now 1855. Okay, so I multiplied every term in the equation by 100, which is the same thing as moving the decimal 2 places to the right. My second equation will stay the same. X plus y equals 35. Okay, so now I basically did that to eliminate the decimals, so I don't have to deal with them. Okay, but I still don't have opposite terms. How would I get opposite terms? Well, now it's decision time. I could eliminate x or I could eliminate y. I'm going to choose to eliminate x. Okay, so if this is 45x, what is the opposite of 45x? You should say negative 45x, right? So how would I get this x term to be negative 45x? You're right, I would need to multiply by negative 45. So put the entire equation in parentheses, and we're going to multiply by negative 45. Multiply by negative 45. So this top equation, equation number 1, is going to stay the same. So I'm just going to bring it down here. I'm going to bring it down. It's 45x plus 65y equals 1855. Okay. The second equation, see how I'm putting the little 1 and 2 to distinguish the first equation from the second equation. The second equation, I distribute the negative 45, so negative 45 times x is negative 45x. Negative 45 times y is negative 45y. Do you see how I'm showing the rainbow here? Negative 45 times 35, that's going to equal negative. And what's 45 times 35? 45 times 35 is 1575. Okay, so now my equations are lined up. I have opposite terms. Next would be to add. Put a little plus sign for add. Draw the equal sign across the problem. 45x plus negative 45x, those cancel, right? They eliminate. They are opposite terms. 65y plus negative 45y, that is 20y, is equal to 1855 plus negative 1575. They have different signs. Subtract, keep the big guy. So my answer is positive 280. If 20y is equal to 280, I solve for y by dividing both sides by 20. Those 20s simplify, and so y is equal to 280 over 20, which is 14. So y equals 14. Now what does y tell me? What did we call y? Y, if you remember, was the number of large sodas. So we found that there's 14 large sodas. And so if we have y, how are we going to get x? We've done L, we've done O, we've done A. Next is S. We need to sub in, right? Sub in that y value to one of the two equations that you wrote. It's going to be easier probably to sub into the second equation, since the second equation that we wrote was x plus y equals 35, right? And we know y is 14, so x plus 14 equals 35. Move 14 to the other side to be able to solve for x. And so x is equal to 35 minus 14 is 21. And what does 21 represent? Well, 21 was the number of small sodas. 21 was the number of small sodas. So now we have solved the system. We've solved this problem, right? We can answer the question now. It says how many of each size soda were sold? Well, small, there were 21 small sodas, and there were 14 large sodas.